don't hesitate to interrupt me and ask, and there is no problem. Okay. So let's start with what is a Slurm. Okay. A Slurm is a powerful resource management and job scheduling. Okay, if you have worked in other clusters or here in the SUK, you have worked with a Slurm. And this system is commonly used for large and small Linux cluster. Okay, Slurm stands for Simple Linux Utility for Resource Management, or as some sorry, that someone the presentation stops by itself now. So this one, Slurm stands for Simple Linux Utility for Resource Management. Okay, or as some prefer, is just a Slurm. Okay, this system has become essential in managing resources efficiently across various environments in high-performance computing. Slurm has developed as a collaborative effort mainly by the Lawrence Livermore National Laboratory in California, in the University of California, with Schmidt MD, that are the developers of Slurm, the Linux Network X, the Hewlett-Packard, and the group Bull. Okay, Bull. I don't know if you know Bull. Before they were Atos, and now I think that their name is Evident. I think they changed their name recently, so now it's Evident. So, the Slurm primary function is to allocate resources for a certain duration of time, okay, and manage the job execution on clusters. It provides a framework to start and execute and monitor work, often for parallel jobs that require multiple resources working together. Sorry. As a job scheduler, Slurm handles a queue of pending work, resolving resource contention among users to ensure that each job is handled according to a priority and resource availability. It's important because there is always, in a cluster that is shared among different users, there is always more compute work to be done than compute resources available at any given moment. Okay. Of course, Slurm is part of a family of resource managers and schedulers. It's not the only one. For example, on this side, you will see in this slide, you can see the load leveler from IBM, the LSF, that is also another one that is very commonly used, the PBS Pro, that it's a payment software, I think, and other ones. Each of them has a specific strengths, but Slurm is very interesting in front of other alternatives because Slurm has a few notable advantages, like it's open source. Okay, it's highly scalable and fault tolerant. It's open source because if you miss some features, you can submit your piece of code to the developers of Slurm as Shed MD, and they will review it and approve it if this piece of code is useful for the user community. Okay, and it's well code, of course. It's also fault tolerant because it's reliable and can adapt to a wide variety of setups. For this reason, it's highly scalable. And Slurm is used around the world in many different organizations, like government laboratories, universities, and companies. And if you go to the web of the top 500 list of supercomputers, you will see that Slurm is widely used in practically 90% of the computers. Okay. If you have worked also in Mare Nostrum 4 or Mare Nostrum 5, you will you have used Slurm. Okay, so it's a proof that it's used in mostly everywhere. Well, if we take Slurm as a resource management, as a resource manager, what does Slurm manage? Well, it manages the hardware of a cluster. Okay, if we remember, as a piece of tip, the cluster is a collection of many separate nodes, okay, servers that are connected via a fast interconnection. Okay, it may be InfiniBand or any other of OmniPath or whatever. And a node is an individual component of an HPC system. Okay, so we generally enter to the cluster using SSH, as you can see in the slide. Enter to the login node, okay, and then we use Slurm in order to talk or work with the compute nodes and the shared disk and the high performance shared disk that are the BGFs, the Scratch, okay, that Adrian told you before. We also have the partitions, okay? The partitions is a way of group nodes, okay? It's a logical group of nodes that share common specs, okay? For example, we have the partition, the standard, that are nodes that have AMD EPYC CPUs. Other partition have the GPUs, okay? And each of them provide different level of computational power, memory and storage. So here we also have the express, as Adrian told you, that the common spec is not the hardware common spec, but is a functionality. Okay, so if you need a job that very quick job, or you need to test some script, you can submit your job to the system, to this express partition, and the job will run. Okay, so Slurm is very useful to use with these partitions to request exactly what we need. Okay, optimizing the resource usage across the cluster. Okay, for example, here a user requests 5 cores, 9 gigabytes, and 1 GPU to the Slurm, and the Slurm will allocate these resources for this user. How much time? How many time? Well, it depends, no? Of course, we are not sending only one job to the system. No, we are sending much jobs. So Slurm can use several scheduling techniques to manage jobs efficiently. Okay, the scheduling, you remember, is the process of determining the next job to run on the resources. Okay, we are going to see only two. The first one is the FIFO, first in, first out scheduling. Okay, that the jobs are processed in the order that they are submitted. Okay, but as you can imagine, this method maybe is not the most efficient way to handle jobs in a shared cluster, high performance cluster. No, for this reason, Slurm can apply the backfill scheduling, it's called, that allows smaller jobs to fill in the gaps of the queue when there are waiting jobs that require larger resources. Okay. In this way, we can maximize the resource used while we are minimizing the idle time of those resources. Okay. This method, the backfilling scheduling, is based on two key parameters. The first one is the priority of your job, okay? And the second one is the time that the system expects that your job will be running. That this time is the time limit that you specify when you submit the job. The first one, the first key parameter is the priority, okay? So you as a user, you cannot control the priority of your job in global, okay? and is set by the system as a linear combination of different factors. Okay, the most important one is the quality of service. Okay, and the quality of service is the QoS that is linked basically with your account. Okay, your account can have a normal priority or low priority if you are a REST user, a class A, class B, class C, depending on your account. Okay, and this is the main factor that will give the priority of your job. Okay. Jobs with higher priority are likely to execute before jobs with lower priority, but it's not always the case, as we will see later. Okay. The second factor important in the priority are the fair share. Okay, the fair share allocates the resources based on the user's historical usage. Okay, and requested and depending on the requested resources. For example, if a user has consumed a lot of resources recently, their new jobs that are sent to the system might be deprioritized to balance the resource allocation fairly between among all the users and all the accounts of the system, of the cluster. Okay. The next one is the age of your job. The age is the time that your jobs spends on queue that are not running, okay, that are pending. So it's this value arrives to a maximum of when the jobs spend is queued in the system for 7 days, okay, and is not valid for dependent jobs. If you send a job that is dependent from the others, this value is not increased. Okay, so if your job waits on the system for 7 days, maybe there is something that it's not working as properly. Okay, and we can review and we can see what is happening. Okay, and finally there is the job size. Okay, the job size refers to the resource requested for the job. Larger jobs receive more priority regarding hardware resources, but not in terms of time. Okay, this factor allows Slurm to prioritize jobs dynamically. Okay, large jobs that maybe are difficult to backfill in the gaps, but they are balanced by this increase in priority. Okay. And finally, there is a nice factor that this nice factor is the only factor that you can control for your jobs. That is a factor that allows you to order your own jobs. Okay, it's an integer that is range from negative value to a positive value, and the lower lower the value. The lower values of these factors increase the job's priority. Okay, so you can establish a new priority in your own jobs using this factor. Okay, as lower is the factor, more priority has the job. Okay, so the nice factor of 0 is the standard, and it will use only the priority of that the Slurm assigns to your job. Yes. Is there any question about priority? If not, we can pass to the second key parameter that is important for backscheduling. That is the time. Okay, the time limit that is what you establish when you submit a job. Each job in a Slurm has a time limit. So the partition has no limit in time, but you have to establish a time limit for your job. And it helps to prevent any single job that monopolize resource indefinitely. Okay. Is a question? No, it's another question. So it's important to be as accurate as possible when you submit a job. I know that it's sometimes it's difficult to be accurate, but when you submit a new job, use a time limit that it's big enough to assure that the job will not be killed by a Slurm. But once you have more or less the idea of the time that the job will spend, decrease this time limit. Okay. Imagine the situation that you are seeing in the slide. That there are 5 jobs in the queue, and a second user send a new job. Okay, this second user has in this situation has a lower priority, and the only factor that are determining if this job will run before or after is the time limit that this user set in the submit time. Okay, so if the user place a time limit much larger than the elapsed time of the job, maybe this job will spend in queue at the end of the queue, okay, and will wait until the other jobs are executed. If this user, for the same calculation, sets a time limit that are much shorter than the other one for the same calculation, only changing the time limit, this job maybe can be backfilled into the gaps of the queue and be executed before. Okay, so we pass from a wait time of 7 hours or days, depending, to a wait time of only 1 day or 1 hour. Okay, only changing the time limit. Again, I know that it's difficult in sometimes, even when you are submitting a new kind of calculation, but it's important to be as accurate as possible. Okay. Then just a little reminding about the commands that we use to connect to the system, because now I'm going to explain you how to launch, how to submit these jobs, and how the jobs are created. Okay, we can submit, we can enter to the cluster with the SSH through the port 2122, and we can transfer the files needed using SCP or FTP or whatever protocol you want to use. Remember that you have 3 main places to work on: the home, the data, and the scratch. And the scratch should be the preferable when you are executing jobs. Okay. So let's look at the job creation. When we submit a job, users create a Slurm job script. Okay, we are going to see the different kind of ways, the different ways to submit a job. But in all these ways, we have to create a submit script. Okay, the first one is the normal. The one is the batch, the batch job. Okay. Here we can see a little bit an example of a script. Okay. Here we can see that in this script we set the parameters of your job, such as the job name, the output file, the partitions, the task or the course, and the time limit. Okay. The only mandatory parameter here, I think, that is the time limit. So you don't start this time limit, this job, you cannot send jobs to the system. Okay. For example, this is these examples that I told you: the job name, the job's standard output file, that is not the output file of your calculation, but is the output file of a Slurm job. Okay, so if you don't redirect the output of your calculation to anywhere, the output will be printed here. Okay, the error file, the partition, the number of tasks, well, what you can see here. The other parameters, if you don't specify them, there are some defaults. Okay, that for a standard partition is 1 core and 1,100 megabytes per core. The FAT is 1 core and more or less 16 gigabytes per core. And the GPU, 32 cores. That this is not a default, but it's a fixed number. It's a ratio fixed by GPU. Okay, if you ask for a 1 GPU, the system will give you 32 cores, and if you ask for 2 GPUs, the system will give you 64 cores. Okay. Then the second part of the script is what you are doing in your calculation. Okay. For example, a general structure that your script can follow is the first, you load the module. The second, you copy the inputs to Scratch and change the working directory because you don't want to work from home. Okay, you go to Scratch. The third, the execution of your calculation, of your application, and fourth, the copy of the outputs from Scratch to home or to the data volume, depending on whatever you want to store them. Because if you leave in the Scratch, if you leave your files in the Scratch, they will be erased after 7 days. Okay, and there is no possibility of restore them. Okay, so please be careful about your files. Okay, I think that there is a question. Is it possible to specify shared RAM memory files so that several jobs do not have to load the same memory to the same file to memory? Well, it depends. It depends on your application, basically. If I understand the question, is it possible? Well, the RAM, okay, the RAM is exclusive for your job. Okay, if I understand the question, the RAM is exclusive for your job, so you cannot share RAM between 2 different jobs. Okay, imagine you are online loads engine. Well, in this case, what you can do is something that we are going to see later. That is using the steps of a job, not a job because the resources that are allocated for a job are exclusive, and for security reasons, these resources cannot be shared with other jobs. So you have 2 alternatives: or you write your files to Scratch or to a hard drive, okay, or using the same job, do some different steps. Okay, I don't know if I answered the question. Module load is mandatory. Use module load. Well, this one, Adrian. Well, it's mandatory depending of your application. Okay, as Adrian is answering you. If you want to use the applications that are installed in the system in the cluster that we have installed, the easiest way is to load the module. Then the module set the environment variables and whatever it needs. Okay, but if you compile the application, of course there is no need of module load. Okay. Well, this Adrian has answered this. Okay, the next one are the steps. Maybe it's useful for you. No, I don't know. Daniel, I think. The steps are a subset of the overall allocation of the job. Okay, they can run sequentially or in parallel, and the division of the job is made into steps to make easier to manage the concurrent processes in a job. Okay, this is a very advanced way of of execute jobs, and in generally maybe is not the best way. Okay, it depends on your application and your needs. More or less. So when you do a submit, what you are doing is requiring some resources for using a specified period of time. Okay. What you do with these resources is up to you. So inside the job, you run srun, as you can see in the example, and srun what do is make use of these resources. Okay, is a command from Slurm, and it's used, for example, for parallel applications. Yeah. So here we are saying to Slurm that we want to use some applications in some of them in some of the resources, and other applications or other whatever in other resources, but inside the same job. Okay, it's all inside the same job. For example, if we submit a job with 2 cores and we use these steps to run one application or one step in one core and the other step in the other core, we can do it in parallel, okay, or we can do it in serial. I don't know if I'm explaining. Yeah. So you submit one job, you execute multiple times, multiple applications, multiple calculations, and then you obtain only one job. Well, only one output. Yeah. Yes, Daniel. Okay. But again, this is maybe it's not the best way of parallelize. Okay, it depends on the application, but there is other better ways. Yes. Another way is the use of arrays, job Slurm arrays. Okay, you can use arrays. You can submit only one job. You can submit only one job and specify to Slurm that this job will be divided into identical jobs, okay? And you will obtain this this number of identical jobs, okay? So you submit once your script, okay? This script submits different jobs, and you obtain the output of the different jobs. It's very useful. For example, well, job arrays. I don't know why it's no. Sorry, that. What? Wait a moment. That PowerPoint is doing strange things. Okay. Okay. So at the end, again, each of the jobs has unique task ID, okay, but follows the same structure. So you submit a job doing one calculation, but changing, for example, the input. So with only one submit, you can work with multiple inputs, okay, with arrays. Follow this. Well, each of them has the unique ID. So these arrays can be identified uniquely. Okay. This is very useful when you are running a collection of inputs, as I told you, like genetic data sequencing. Okay, like array indices, and this. The other one, the last one, is the dependency of the jobs. Okay, when you submit a job, you can submit another job and only allow the run of the second job when the first finish, okay, properly or had a fail or whatever. Here in the example, we submit 2 jobs, okay, A and B. for doing a pre-processing, the whatever. Okay. We submit 3 more jobs that will do the analysis of this data, this processed data, and when the analysis of the data has end, then the last job, the job X, will verify the output of your jobs. Okay, it's very useful when you have different workflow that have different steps, and is it possible to use SnakeMake or Nextflow to control the submission? Yes, we have Nextflow installed. Okay, so Nextflow, in essential, Nextflow do this. Okay, so Nextflow, you send a job with 1 core to the system. Well, you know, maybe you know how it does work, but you send a job with 1 core to the system, and this job is a master job that sends multiple jobs depending on the workflow that you are running. No, so this is more or less the same philosophy, but yes, you can use Nextflow. Okay? But inside the Slurm, so you send a job to a Slurm that will run Nextflow, and Nextflow will send more jobs to the Slurm that will run the calculation that you need. Okay. Well, there are different types of dependency, depending of whatever you need. No, after the start, after the end, if the job ends correctly, ends with a fail. Well, there are multiple options here. So at the end, jobs can go through various through different stages in a Slurm. Okay, they go from pending to running. Okay, when you submit a job, they go from pending to running, then to completing, and finally to complete. Maybe in some cases you can find a job with a different state. For example, if the state is timeout or fail, indicate that the job has failed for some reason. If it's timeout, it's because your time is not large enough, and the Slurm has killed your job. Okay. Well, this is an assembly more or less, but more or less is what you will find in the cluster. So just to finish, we are going to see some important comments for Slurm to see all these resource manager, the scheduling, and the send of the job. No, for example, when you want to submit a job, the first one is use of sinfo to see what is happening in the cluster, how the nodes are, see if the partition is up or if the partition is down, how many partitions are, how many nodes are available, etc., etc. We can see the time limit of the partitions. This is with the sinfo of Slurm. Also, you can use the status command. The status command will give you the same information, but more nicely and more formatted. Okay, you can see at a glance what is the occupation of the machine. Okay, and the different partitions. So you have created your file, and you send your file to the Slurm using the sbatch command. Okay, the system will give you a message saying that the batch is submitted, and will give you a job ID. Okay, if you do an SQ with this job ID or with your name or with --me, will give you, for example, if you do it with SQ --me, will give you only the jobs that are yours jobs. Okay, and here the important information is the state of your job, the why is not running if it's not running, and if it's running, where is running, and the time that has been running. Okay. Then while your job is running, if you do the SQ, you will see this, well, this information, the time and the node where it is running. And you can retrieve some important information from the job using the sstat, okay? For example, the maximum memory used for your job and the process IDs that are assigned to the whatever this is running, no, inside your job. Then finally, your job goes to the completing state. Your calculation just ends with an SQ. You see this. Okay, you see the state is CG, that is completing. And finally, you can retrieve some historical information for your jobs using the SICCT. Okay, that this will print you all the information of your jobs, the state of your past and current jobs, and some more information. These commands are widely configurable, and you can format the output of the info that you want to obtain. And of course, if your job goes in a way that you don't expect, you can cancel the job for whatever reason, okay, with a scancel command. Okay? And if you do the SCTT, SHCCT, you will see that the state of your job is canceled, okay, because you cancel. So just for finish, remember that you have to choose first the most suitable partition, use the Scratch as working directory, okay, during your jobs. Move only the necessary files, so move only the input files that you will use and the output that you need to retrieve. Not move. Please do not move all the files of your directories, because it's a spend of time for you and it's useless. Okay, and keep your important files on home or on data, but especially on home, because is where the snapshots are made. Okay, so if you delete some files for error, we are going to get them back. Okay. When a job fails, can you see why was it killed? Well, the fail status, it depends a lot about depends on your application. Okay, in some applications propagate the error that they do. Well, the reason why they end, no, and the state of the job is showed as fail. Okay, but some applications no. Some applications do not propagate the error, and simply they say that the calculation ends properly and just it. Okay. Depending on the failure of your job, if it's a timeout, you will see that it's a timeout. If it's out of memory, you will in generally see that is out of memory. I say generally because it again depends on your application. For example, Gaussian is an application that in some moments when they change the file that is executing, okay, memory increase a lot. If this increase is sharp enough, maybe Slurm cannot detect this out of memory. Okay, the system kills the job, but Slurm does not know why it's killed. Okay, so the job maybe is has finally with a state of completed, but it really has been killed by an out of memory. Okay, so it's important to know your applications that you are running, and it's important to be aware of what you are doing. Okay, in order to know why a job fails. And well, that's it. If anyone has more questions about anything about the Slurm or the system, you will, Christian will give you some examples of sending jobs to the system, and you will see in vivo, no, what is happening to the cluster in the cluster when you submit jobs. No questions? Okay, so just enjoy your Slurm because it's highly addictive. And thank you for attention. If you have any feedback or any problem, you can contact us through the portal, or if you have feedback about my presentation, you can write me through the email, okay? So let me end the presentation. I don't know how to. Si no, aquí, ahora sí. So, Christian, the floor is yours.
Thank you, Ismael. I'm Christian. Can you hear me?